Okay, we're going to continue today in Chapter 1, Section 4, beginning with Example 7. And this is where we begin to talk about slope-intercept form. So I'm not going to spend a big time introducing this because I feel confident this is the one you're the most familiar with. Okay, slope-intercept form is y equals mx plus b. We know that m represents the slope and the b represents the y-intercept. And if you don't know that, write it down, but again, I think most of you probably do. Now, for this problem, it tells me to find the slope and the y-intercept of the following equation, which is 2x plus 4y equals 8. And then I have to graph this equation. So, first thing, I cannot find the slope and the y-intercept until my equation is in slope-intercept form. To be in slope-intercept form, the y must be isolated. It must be by itself. So how can I get the y isolated? Move the 2x over, it becomes negative. 4y equals negative 2x plus 8. I'm going to divide everything by 4. That leaves me with y equals negative 1/2 x plus 2. Okay, so the slope of this line is negative 1/2, and the y-intercept is 2. Okay, now that I've identified the slope and y-intercept, it tells me I must graph this equation. Well, I don't know where my grid's not there. Okay, so now that I've identified the slope and the y-intercept, I just have to graph this line. We graph the line by going to the y-intercept, which is 2, and plotting that point. So go up the y-axis to 2, there. And then I use the slope to find the next point. So the slope being negative 1/2 means I'm going to go down 1 to the right 2. Now again, the way that I like to explain it, you have to choose to put the negative in either the numerator or the denominator. So I chose to put it in the numerator to make that a negative 1, which means you have to go down 1. Now I can do that as many times as I'd like. So from that point, I'm going to go down 1 to the right 2 again. The worse you are at drawing straight lines, the more times you need to do this. Now, I'm going to put the negative in the denominator, and the slope is positive 1 over negative 2. So I can go up 1, left 2. There we go, get a good amount of points. I'm going to draw my line through them. I'll get one I like here in a second. That's okay. Okay, now I'm looking at example 8. We've got an equation that's in standard form. Okay, standard form means the x and y are on the same side. The a term is positive. Okay, but that's not what we're concerned with at the moment. It tells me to graph this equation by finding its intercepts. So let's do that. How can I find the intercepts of this equation? Well, first let's find the x-intercepts. How do we do that? 0 for y. So it'd be 2x plus 4 times 0 equals 8. This says that 2x is equal to 8 divided by 2. We find the x-intercept is 4. So that means the point 4, 0 is on my graph. Now, let's find the y-intercept. How do we find the y-intercept? 0 for x. So that gives 2 times 0 plus 4y equals 8. All right, simplifying that, that's 4y is equal to 8. Then we divide both sides by 4 to give y is equal to 2. So that means the point 0, 2 is on my graph. So now I know 2 points. I know it includes the point 4, 0, and it includes the point 0, 2. Okay, so I'm going to plot those points. First, 4, 0 is here. And then the point 0, 2 is here. Now that's all I need is 2 points. When I have 2 points, I can draw a line through them. Again, I can't draw a very good line, but that's all you need are those 2 points. Okay, the next thing they talk about are parallel lines. So, parallel lines, as you recall, are 2 lines that kind of run side by side, right? They never cross each other if you're dealing with a 2D plane. So what could we say about 2 lines that are parallel? Think about the way we describe lines with intercepts and slopes.
They'll have the same slope, just different x and y's. Intercept.
Right. So in order for 2 lines to be parallel, they have to have the exact same slope, but they have to have different y-intercepts. All right, what would happen if they had the same y-intercept? Be the same line. So a line can't be parallel to itself. So it has to have the same slope but different y-intercepts. So how could I prove that these 2 lines are parallel? Find the slope. Very good. And the best way to find the slope is to put both lines in slope-intercept form. Okay, so I'm going to start with line 1 here, which is 2x plus 3y equals 6. Putting that in slope-intercept form means I'm going to get the y by itself. So I move the 2x over. When I do that, it becomes 3y equals negative 2x plus 6. Now we're going to divide everything by 3. That gives us y equals negative 2/3 x plus 2. Okay, so what's the slope of this line, the blue line? It's what? Very good, negative 2/3. So if the slope of the green line is the same, then I can say they're parallel. Okay, so again, I'm going to copy the line down. Now to find the slope, I need to get in slope-intercept form. So I move the 4x to the other side. It becomes negative. So that's 6y equals negative 4x. Then I'm going to divide both sides by 6. And that gives y equals negative 4/6, which I simplified to be negative 2/3 x. And then what's the y-intercept of the green line? 0. Okay, that means it crosses the y-axis at 0. This one is at 2, so they're not the same line, but their slopes are the same, so they are parallel. Okay, here's the next one. We're told to find an equation for a line that contains the point 2, negative 3, and is parallel to this line. Okay, so I'm looking for my own line. I know it goes through a point and is parallel to another one. So what does being parallel to another line help me with finding an equation for my slope? We know that it must have the same slope. Okay, so what's the slope of this line 2x plus y equals 6? Well, how could I find the slope? Okay, get y by itself. I move the 2x over. It becomes negative. So what is the slope of this line here then? The slope is negative 2 over 1. So now I know the slope of my line, and I know a point on my line. I know the slope and a point. I know the slope and a point. I'm going to use point-slope form, which is y minus y1, which is negative 3. So that's y plus 3 equals m times x minus x1. Now, I'm going to stop right here. because I have an equation for the line. Now, if you decide to put it in slope-intercept form to graph it, I'm fine with that. But I'm just going to leave it like this.
Can you go further?
You can, I mean, if you want to. Okay, first, let's graph the line that my line is parallel to. So we got it in slope-intercept form here. So it has a y-intercept of 6. Oh, that's the very top. Okay, I place that there. And then the slope is -2, which means I go down 2 to the right 1. Right, I heard Hayden say earlier, it's -2 over 1, which is correct. That's what we're going to do, is go down 2, right 1. And then connecting all those points. Gives me that line. Good questions there. Now, let's look at the other line, which is the line that I found the equation for. I know a point that it goes through, right? It goes through 2, -3. So I'm just going to plot that point. 2, -3 is right there. And then I know the slope of my line is -2. So I'm going to go down 2 to the right 1. Or I could go up 2 to the left 1. Very good. And right here would be that line. So you can see how they're never going to intersect because they have the same tilt or the same slope. Okay, so we're going to do a quick review here of parallel lines, and we're going to introduce a new word, or a new kind of lines, which you've heard of before. I spelled parallel wrong. There we go. Okay, so parallel lines, they have the same slope. And when you graph them, they look like this. Never intersecting. Okay, there's another kind of way we classify lines. We can call lines perpendicular.
Isn't this the one with the slope that flips up?
Okay, so when I graph perpendicular lines, when they intersect, they should intersect at right angles. Right? The angles formed by their intersection forms a 90-degree angle. And then we talk about their slopes as having opposite reciprocal slopes. So these have opposite reciprocal slopes. Okay, so let's do an example of this, because every year that I go over this, people only do half of what opposite reciprocal means. There's a reason we have to use 2 words to describe it. That's because there are 2 things that happen. The opposite talks about changing the sign of our number. So if it was positive, it becomes negative. If it was negative, we make it positive. And then reciprocal is to flip the fraction. Okay, so let's take a minute here. Let's list some opposite reciprocal slopes. Because again, this is a problem that I see students have all the time. If the slope was 2, what would be a slope perpendicular to that line?
-1.
It would be -1/2. Remember, you have to do the opposite reciprocal. You must change the sign and change the number. Now, what if my slope was -4/3? What would be the perpendicular slope to that? +3/4. You're bored to death. Good. That means that we should know what we're doing. Now, here's one that's a little trickier. What if my slope was 1.6. Okay, what would the opposite reciprocal slope be there?
Negative 8
We know it's going to be negative.
5 over 8.
Negative 5 over 8. So again, you can use your calculator, right, to convert 1.6 to a fraction and then flip it to find the reciprocal.
That would be hard to have a slope of
Okay, so here it tells us to find an equation of a line that contains the point 1, negative 2 and is perpendicular to the line x plus 3y equals 6. So now if it's perpendicular to this line, then that means it has to have an opposite reciprocal slope. So let's find out what the slope of that line is. I need to get the y by itself, so I move the x over, it becomes negative. So that's 3y equals negative x plus 6. Now that I'm going to divide everything by 3, that gives y is equal to negative 1/3 x plus 2. So now what's the slope of this line? It's negative 1/3. Now I know my line is perpendicular to this line.
3.
So the slope of my line is going to be positive 3. Very good. So I know the slope of my line, and I know a point that's on my line. So I'm going to use point slope form. Okay, so y minus y1, which is negative 2, so that's plus 2, equals m, which is 3, times x minus x1, which is 1. And here's the equation of that line. Okay, then the last step here, I need to graph both of these lines. So I'm going to first graph this yellow line, the line that's perpendicular to the line I just found. Okay, we see that the y-intercept of that line is 2. So I plot my y-intercept at 2. And the slope is negative 1/3, which means I go down 1 to the right 3. I can do that a couple of times in both directions. Okay, and here is the graph of that line. Well, we're going to try to get the graph of that line. There we go. I put arrows. Now, for the line that I just found the equation for, I know a point and I know the slope. So I know it goes through the point 1, negative 2. So I plot that point. And then I see that the slope is 3. So I'm going to rise 3, run 1. Rise 3, run 1. Right, and then I could go down 3 to the left 1. Okay, and through all those points there, I have that line. Okay, now here are your homework problems for today.